How do you map water drainage basins? Have you ever wondered how scientists and researchers figure out where all the water in a region flows? Understanding how to map water drainage basins is key to that process. Let's break it down step by step. First, you need to identify the outlet or pour point. This is the lowest spot where water leaves the basin, like where a river meets a lake or ocean. Knowing this point is essential because it serves as the destination for all the water that flows through the basin. Next, you trace the drainage divide. This involves following the ridges and high points of land surrounding the outlet. These natural features act as barriers that separate one drainage basin from another. You can use topographic maps or elevation data to help find these ridgelines. Once you have the outlet and the drainage divide, it's time to enclose the area where all the surface runoff flows toward the outlet. Make sure that any water falling outside this boundary will drain elsewhere. This ensures that the basin you are mapping accurately reflects the area contributing to the outlet. To confirm that your boundary follows the natural topography, look at the contour lines on your maps. Ridges will appear as bent contour lines with the peaks pointing downhill. This visual cue helps ensure your mapping is accurate. In today's world, technology can make this process easier. Digital elevation models and geographic information system software can automate many steps. For example, these tools can fill in low spots in elevation data to create continuous flow paths. They can also calculate flow direction for each cell in the model, showing where water would naturally flow. With geographic information systems, you can automatically delineate watershed boundaries based on flow direction and your chosen outlet. Plus, you can manually edit the map to break large basins into smaller subwatersheds if needed. Mapping drainage basins also involves looking at their shape and size. These factors can influence how quickly water moves through the area. For instance, a long and narrow basin may allow water to reach the outlet faster than a wide and shallow one. The practical uses of mapping drainage basins are vast. It plays a role in water resource management, flood prediction, pollution control, and even ecosystem conservation. By understanding these boundaries, scientists and engineers can model water flow, assess how land use changes impact the environment, and design effective infrastructure for water management. So, mapping a drainage basin combines topographic analysis with hydrologic principles. With modern technology, this process is more precise and accessible than ever, making it a vital tool in environmental and water science.